Hello, my name is Tushar Singh, and in this video we are going to discuss third internal test paper, subject algorithm design and analysis. Let's get started. All the questions are going to be multiple choice question. Question number 1. In Strassens matrix multiplication, the number of multiplication needed to multiply two 2 by 2 matrices is, the correct option is 7. In Strassens matrix multiplication algorithm, the number of multiplication needed to multiply two 2 by 2 matrices is 7. The Huffman code is a type of, and the correct option is, the Huffman code is a type of lossless compression algorithm. Huffman coding is commonly used to compress data by assigning variable length codes to different symbols in the input. These codes are constructed in such a way that more frequently occurring symbols are assigned shorter code, while the less frequent symbols are assigned a longer code. In Kruskal's algorithm, what is the time complexity for sorting the edges of the graph? In Kruskal algorithm, the time complexity for sorting the edges of the graph is typically O edge log edge, where E represents the number of edges. To understand this, let's break it down. Kruskal's algorithm involves sorting the edges in non-decreasing order to reduce their weight. Typically, this is done using a sorting algorithm such as quicksort or merge sort, which have average case time complexity of O n log n, where n is the number of element to be stored. In Prim's algorithm, what is the time complexity for finding the minimum weight edge from a vertices? And the correct option is, in Prim's algorithm, finding the minimum weight edge for a vertices typically takes O n time complexity, where n represents the number of vertices in the graph. Depth first search DFS can be used to find. The correct answer is option B, the longest path between two nodes in a graph. DFS can be used to explore paths in a graph and keep tracking of the longest path found during the traversal. It can be used to find the longest path between two nodes in a graph. Breadth first search can be used to find option A, the shortest path between two nodes. It is the correct answer. BFS is a graph traversal algorithm that explore all vertices of a graph in breadth first order, starting from given source vertices. It explores all the vertices at the same level before moving on to the vertices at the next level. This priority of BFS makes it well suited for finding the shortest path between two nodes in an unweighted or ununiform graph. Question 7. Dynamic programming can be used to solve problem that exhibits. The correct answer is optimal substructure and overlapping subproblems. Optimal substructure means that the optimal solution to a larger problem can be constructed from an optional solution to its smaller subproblem. Overlapping subproblem means that the same subproblem can be solved multiple times during the computation. Question number 8. The matrix chain multiplication can be solved using. The correct answer is dynamic programming. Matrix chain multiplication problem involves finding the most effective way to multiply a series of matrices together. The longest common subsequence problem can be solved using. The correct answer is dynamic programming. LCS problem involves finding the longest subsequence that is common to two or more sequences. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining element. Question number 10. In Strassens algorithm, the matrices can be multiplied or divided into. The correct answer is two equal parts. Question number 11. The running time of Strassens algorithm is. The correct option is big O of n 2.81, which is less than standard matrix multiplication O n cube. Huffman codes are prefix code, which means that the correct option is no code is a prefix of any other code. Each symbol in the input is assigned a unique binary code. These codes are constructed in such a way that no code assigned to one symbol is prefixed to the code assigned to another symbol. The minimum number of bits required to represent the symbols in a set using Huffman code is, the correct option is less than the number of symbols. One key benefit of Huffman coding is its ability to assign shorter codes to more frequent symbols and longer codes to less frequent symbols. What is the time complexity of standard matrix multiplication algorithm? The correct answer is O n cube, because it requires 8 multiplication. In Strassens algorithm, what is the base case for the recursive algorithm? The base case is when the matrices are 2 by 2. The Huffman codes are assigned shorter codes to. The correct option is symbol with high probability. In Kruskal's algorithm, how many times are the edges of the graph sorted? The correct answer is 1, which is at the beginning of the Kruskal's algorithm. In Prim's algorithm can be used to find the minimum spanning tree of, and the correct answer is an undirected graph. The time complexity of BFS is big O of n, option A. The time complexity of DFS is also same, option A, big O of n. What is the time complexity of dynamic programming approach for solving the longest common subsequence problem? The correct option is O n square. The table has dimension n plus 1 into m plus 1, where n and m are the lengths of the input sequences. Filling the table takes O n m times, since each entry in the table is computed based on the value of its adjacent entries. In matrix chain multiplication problem, the number of matrices to be multiplied is, the correct option is given as input to the algorithm. The time complexity depends on the input given to the algorithm. Question 23. What is the time complexity of the dynamic programming approach for solving the matrix chain multiplication problem? The correct option is O n cube because it requires 8 multiplication. Which of the following algorithm uses a greedy approach? The correct answer is Kruskal's algorithm and Prim's algorithm, which both uses greedy algorithm to generate a minimum spanning tree of undirected graph. The longest common subsequence problem can be solved using option B, DNA sequencing problem, which is used to match the genomes of two organisms, can be solved using longest common subsequence problem. The running time of Strassens is faster than the standard matrix multiplication algorithm for matrices of size. The correct option is D, 4 by 4. In Huffman code, the average length of the code word is option B, less than the number of symbols. The average length of the code word in Huffman code is generally less than the number of symbols. This is because frequently occurring symbols which have shorter codes contribute more to the overall length, while less frequent symbols with longer code have a smaller impact on average. What is the time complexity of dynamic programming approach to solve matrix chain multiplication problem? Option is O n cube. What is the maximum number of subproblems that needed to be solved in the dynamic programming approach for matrix chain multiplication problem for n matrices? The correct option is n square. The dynamic programming approach for matrix chain multiplication problem, we built a table to store intermediate result. The table is typically represented as a 2D array where the rows and columns corresponding to the different subchains of the matrices. Since there are n rows and n columns in the table, total number of entries in the table is n square. Therefore, the time complexity is n square. In the dynamic programming approach to solve the longest common subsequence problem, which is what is the recurrence relation used to calculate length of the LCS? The correct answer is option B, LCS I comma j maximum of LCS I minus 1 comma j LCS of I j minus 1 if xi not equal to yj. In the dynamic programming approach to solve longest common subsequence problem, what is the time complexity to print the result? The time complexity is O(n) because we visit each cell in the table exactly once while backtracking through the LCS path. What is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices? The option is big O of n cube. What is the time complexity of dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices using memoization? The option is same, B, O n cube. Memoization is a technique used to store the result of expensive function calls and reuse them when the same input occurs again. In the context of matrix chain multiplication problem, memoization can be used to avoid recomputing solutions for the same subproblem. Which of the following algorithm can be used to solve the longest common subsequence problem? Option B, dynamic programming. Which of the following algorithm can be used to matrix chain multiplication problem? Option D, dynamic programming. In dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplication required to multiply n matrices? The correct option is m0, n minus 1. Each entry mij in the table represent minimum number of scalar multiplication needed to multiply the matrices from matrix I to j. Therefore, to find the minimum number of scalar multiplication required to multiply n matrices, we need to look at the entry m0, n minus 1 in the table. In the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplication required to multiply a chain of matrices of length n minus 1? The correct option is B, m0, n minus 1. Each entry mij in the table represent the minimum number of scalar multiplications needed to multiply the matrices from matrix I to matrix j. Since the matrices are numbered from 0 to n minus 1, the minimum number of scalar multiplication needed to multiply a chain of length n minus 1 is given by m0, n minus 1. Which of the following is not a subproblem of dynamic programming approach to solve the longest common subsequence problem? The correct option is D, LCS I plus 1, j plus 1. Question 39. The dynamic programming approach to solve the longest common subsequence problem has time complexity of, the correct option is O(n) square. The time complexity of constructing the table is O(n) square, where n is the length of input sequence. This is because we need to consider all pair of indices I, j to fill the table entries. Last question, number 40. What is the difference between Prim's algorithm and Kruskal's algorithm for finding minimum spanning tree of the graph? The correct option is D, all of the above. Main difference between Prim's and Kruskal's algorithm for finding minimum spanning tree of a graph are: Prim's start with an arbitrary node and starts with adding the shortest edge from the set of available edges, while Kruskal algorithm starts with the shortest edge and adds in increasing order of their weight. Prim's algorithm uses a priority queue to select the next edge and add to the tree, while Kruskal uses disjoint set data structure to maintain the set of connected graph. Prim's algorithm always produces a connected tree, while Kruskal's algorithm may produce a forest of disconnected tree. Therefore, the correct option is D, all of the above, as all the statements mentioned in option A, B, and C accurately describe the difference between Prim's algorithm and Kruskal's algorithm for finding minimum spanning tree of a graph. Thank you for watching the video.